right. Well, here's an introduction to statics. So, statics is the study of forces and their effects on a system in a state of rest or uniform motion. That's what statics is. All right. It's a system that allows a body to stay at rest or uniform motion. So, Newton's first law of motion, the law of inertia, an object in a state of rest or uniform motion will continue to be so unless acted upon a net force. Okay, so this is very important for structures and things of that nature. All right, so Newton's second law of motion, the acceleration of an object is proportional to the net force acting on the object and inversely proportional to the object's mass. Okay, so force equals mass times acceleration, and you'll learn about that more later in this class. And of course, you'll be able to be well versed in it in physics. So here's the important part where we start to look at bridges and such. For every action, there's an equal and opposite reaction force, and this is Newton's third law of motion. So, here, for static equilibrium, a condition where there is not a net external force acting upon a particle or a rigid body and the body remains at rest or continues at a constant velocity. As you can see here, so that's a open ocean drill rig, and very important to have static principles there. Not that that's not going to move, okay? There is going to be some movement. Obviously, you're in the middle of the ocean, and that's designed into it so that the body can give and is not totally rigid. So here we have uh, the state in which there are no unbalanced forces acting on a body. So some of the forces in the x direction must equal zero, and some of the forces in the y direction must equal zero. So you see balanced, and then there's a bridge that failed. Okay, so there you go. Um, Rotational equilibrium is the state in which the sum of all the clockwise moments equals the sum of all the counterclockwise moments about a pivot point. So some of the moments must also equal zero. Okay, that's a zero there. Here, it's for some reason it. All right, then we have scalar quantities, and they're a physical quantity that has magnitude only, mass, length, time, volume, temperature, pressure, speed. Those are scalar. And then we have vector quantities, which have a physical quantity that has both a magnitude and direction. Example, position, velocity, force, and moment. So, what is a force? The pushing or pulling interaction of objects. So, a vector quantity defined by its known magnitude, direction. In addition, the point of application of a vector is important. Okay, so here we have um, the force units. British system of units is pound force, and the international system of units is in newtons. And then the conversion between the units is 1 pound-foot is equal to 4.48 newtons, whereas 1 newton is equal to 0.2248 pound-feet. Forces always occur in pairs acting on two different objects. Force pairs act in opposite directions and have the same magnitude. Okay, so a single force can be replaced by a component force if their combination produces the same effect as the original force. All right, so here you have a single force that has the same effect as two or more concurrent forces. So here you have a 5 pound. You have a push with 5 pound feet and a pull with 2 pound feet. The resultant of that obviously is 7 pound feet. Whereas here you have a block at the bottom where you have a push of 5 pound foot and you have 2 pound feet resistant, gives us a resultant of 3. Okay, why are we not moving? Okay, we might be stuck. Nope, that was the last one. Okie doke. So that's it for now.